In this project, you are going to implement a binary search. A binary search is an algorithm for finding a word very quickly in a sorted list of words. Notice this list is sorted. Remember in the last one you did a sequential search, and that actually works on any list of words. We did it on an unsorted list. Well, this is alphabetized. So you are going to implement this block which finds a word in a list of sorted words. And it either returns the position, returns the index of that word, or a -1 if it's not found. So you're going to implement this thing, but instead of showing it to you on this 4,000 list word, I'm going to show you a simpler example, but your algorithm is going to work exactly the same. So I made up a list of 10 words called foods, as I often do, and you're going to implement this block by making a few variables. A variable that represents the first index, minimum is number 1, so starting position. A variable that represents the last item, item 10 is the last item. And then you're going to calculate the middle index by finding the average. 10 plus 1 is 11, divided by 2 is 5.5. I rounded, used the round function to get 6. Great. So the way this works is I'm going to repeatedly check to see if the item that I'm looking for is equal to the middle, less than the middle, or greater than the middle. And this is called a binary search because every time I do this, I can chop my list in half. So let's pretend like that I'm looking for the word fig. I'll check the middle. Is it less than, greater than, or equal to the middle? Well, fig is less than lemons. It comes before lemons. So now I know that I'm looking in the top half of the list. I can actually take my maximum and move it one past. Notice I'm going one past the middle. I don't stop in the middle. I know it's the top half above the middle. Great. So I know I'm in this half of the list. See, I chopped it in half. Now I'm going to recalculate the middle. 5 plus 1 is 6, divided by 2 is 3. And I'm going to repeat this procedure. Is it equal to the middle? Is it greater than? Is it less than the middle? Remember, I'm looking for fig. It's greater than the middle. It's greater than coconut. So I'm going to move the minimum one past. There it is right there. And I'm going to recalculate. That's 9 divided by 2 is 4.5. I'll round to 5. So I'm moving my middle to 5. Okay. Is it greater than, less than, or equal to grape? It is less than. So now I'm going to take my maximum and move it one past the middle. Always one past. One past like that. Recalculate the middle. Let's see, that's 7 divided by 2 is 3.5. I'll round to 4, so I move my middle to 4. Greater than or equal to, or less, less than, greater than, or equal to the middle. It is equal. There is fig right there at middle, so I'm done. I found it. So my stopping condition is going to be either I have found the item at the middle, or you'll notice the other thing that happened is the maximum became less than the minimum. Right? The minimum is now greater than the maximum. Let's do one more where the word is not there real quick, and so I think you can see what happens. Again, you're going to keep repeating until either one of two things happens. Either the word that you're looking for is at the middle, or until your maximum and minimum have crossed places. So let's say I'm looking for a word that's not there, like pizza. Okay, I'm looking for pizza. I find the min, the max, I calculate the middle. Is pizza greater than or equal to lemons? Well, it comes after, so I move my minimum one past. Alrighty, recalculate. So let's see, that's 17 divided by 2 is 8.5, so I'm rounding to 9. If I grab this, move it down to 9, okay, is pizza equal to this, greater than, or less than? Well, pizza is greater than pineapple. Comes after pineapple, right? So I'm going to move the minimum one past that, which is 10. Now I recalculate. These are both pointing at 10. So when I find the average, 10 plus 10 is 20, divided by 2 is 10. Everybody happens to be pointing at 10 right now. Okay. Is the thing that I'm looking for, pizza, equal to strawberry, less than or greater than? It's less than, so I'm supposed to take my maximum and move it one past the middle. So it goes one above it. Great. Recalculate. So that's 19 divided by 2 is 9.5. It rounds to 10. This guy does not move anymore. The mid stays pointing at this. But I'm done. I know that I'm done because, again, one of two things happens. Either I find the item that I'm looking for, or the maximum and minimum switch places. So if the maximum and minimum have switched places and I have not found the item, it's not at the minimum, then I know that it's not there, and I'm going to return a -1. So hopefully this algorithm, I went pretty quick, but hopefully it makes sense. You got to find the maximum index, the minimum index, and the middle index, and then you check to see, is it greater than the middle, less than the middle, equal to the middle, and then you kind of have to repeat that process. So this is a tricky one. This is an advanced topic, but you can do it, so get to work.